I have here 3 small beakers. Each one of them has a 10 molar hydrochloric acid solution in it, and we're going to see how it reacts with some metals. The first one, I'm going to put in some rolled up copper wire, and if you look at the copper, it's pretty clear that pretty much absolutely nothing is going on. Hydrochloric acid is not reactive with copper. Into the second one, I'm going to drop a small pellet of zinc, and we can see that the zinc begins right away reacting pretty vigorously with the hydrochloric acid to form hydrogen gas and zinc chloride. For our third solution, we're going to drop in a penny. Now, most people forget that pennies are made mostly of zinc with a thin copper coating on the outside. So if you have an undamaged penny, your penny should just look like the nice bright copper wire that we have here. However, if there's any break in the copper coating of the penny, the zinc is going to be able to have the hydrochloric acid access it, and when it does, we're going to have the zinc dissolving away from the inside of the penny, just like this one is here. So here's my penny. I'm going to throw it in, and I have scratched this penny just a little bit on the side. It's hard to see in the video, but there are some bubbles coming up right over there at the bottom of the penny along the edge of the beaker. We're going to let that sit overnight and give it some time for all of the zinc to dissolve away and see what we're left with in the morning. I've set up here for the 2 single replacement reactions that are part of our overall reactions lab. And the first one we're going to do, the test tube on the left, I have plain water. And we're going to add some chunks of little turnings of magnesium metal. And when magnesium reacts with water, we should see a relatively slow reaction going on that produces hydrogen gas and magnesium hydroxide. Now that is very difficult to see, but if we zoom in, there are some very tiny bubbles forming from the magnesium down at the bottom of the water. Those bubbles are tiny bubbles of hydrogen gas as the magnesium reacts. Our final single replacement reaction is the reaction between barium chloride and solid tin metal. Now, if we look on our activity series, the activity series tells us that tin and barium chloride should not show any reaction at all because barium is much higher in the activity series than tin. And when we look at the reality of this, we find there is no reaction at all going on between the tin and the barium.